Alright, welcome to section 4.4. So, we're looking at adding and subtracting functions. Alright, so if you have a function f of x and you had a function g of x, the notation here, f plus g of x, is basically saying take the function f of x and then add to it g of x. So since it's addition, it's okay, it is commutative, but for example, if we had g plus f of x, we would still do the g of x and then the f of x. And once again, you can look on page 304 for the more in-depth definition there. Let's take a look at example 1. Find the following given the functions f of x equals x squared plus 1 and g of x equals negative x squared minus 4x plus 5. So let's see, what do we have here? For a, we have f plus g of x. So rewriting this, we know that this is supposed to equal f of x plus g of x. Well, what is f of x? F of x is x squared plus 1, so let's go ahead and plop that in. X squared plus 1. And then what does g of x equal? G of x equals negative x squared minus 4x plus 5. So if you see, all we did was we swapped out each of the functions into our equation. Now I'm going to go ahead and drop the parentheses, so we have x squared plus 1 plus, or we can just write negative x squared minus 4x plus 5, and all we can do now is combine like terms. So we have 1x squared minus x squared, well those guys cancel out. Then we have positive 1 and 5. Okay, so 1 plus 5, that equals 6. And lastly, we have the negative 4x, but there is no like term for that one. So we'll just bring it down. And then to write our answer in descending powers, we'll go ahead and do negative 4x plus 6. Okay, and once again, notice while I'm solving, I do include, or not while I'm solving, while I'm simplifying, I include my equal signs along the side. Now let's take a look at B. B is a little different. It has f plus g, but this time instead of x, we have something new. We're going to be replacing all of our x values with 2. So instead of x, we'll swap them out for 2. But I'm going to go ahead and set this up the same way we did before. We know that f plus g of 2 is going to be f of, except this time it'll be f of 2 plus g of 2. Okay, so that means when I rewrite my functions, wherever I see an x, I'm going to be replacing it with what? With 2. So here I'll replace that with 2, that x with 2, and that x with 2. So that'll be, let's see, we know it should be x squared, but instead of x, we're using 2, so 2 squared plus 1. That was my f of 2. And then g of 2. Once again, we're replacing the x values with 2. So plus negative 2 squared. Then we have minus 4 times the 2. And lastly, plus the 5. Alright, simplifying. Let's go ahead and simplify this inside first. I'll keep the parentheses since we're still simplifying. So 2 squared is going to be 4 plus 1 plus, and then we have over here, let's simplify this one. We have negative 2 squared, so that'll be negative 4, minus 4 times 2, that'll be negative 8, plus 5. And still simplifying, 4 plus 1 is 5, plus, and then negative 4 minus 8, so that's going to be negative 12, plus 5, so that'll be negative 7. Alright, and then we can go ahead and drop the parentheses, so we have 5 minus 7. 5 minus 7 is going to be negative 2. Aha, so notice, when we replaced our x value with a number, that's when we end up with an actual number value instead of just another polynomial. So if we don't replace our x with a number, if we just keep x in the function notation there, we'll end up with sort of another polynomial, which is the combined version of the original polynomials f and g. Okay, let's take a look at the last example, C. So this one is f minus g of 0. Oh, I realized I forgot to introduce that. So f minus g of 0, if I go up ahead here and I erase this, f minus g of 0, what would we get? Well, f minus g of x, let's go ahead back to the very beginning, f minus g of x is going to give us, very similar to the addition, it's just going to be f of x minus g of x. And careful, this one's not commutative, which means whichever function is first needs to stay first in the beginning, all right? Whichever function is last needs to stay last. Let's go ahead and do that. So that means we have f of 0 minus g of 0, because we have that subtraction. And then what is f of 0? Well, similar idea as we had with b. We're going to be replacing x with 0 this time. So we'll replace x with 0. So that'll be 0 squared plus 1. And then we have, remember we have that minus we got to bring down, minus. Now we want g of 0. Ooh, I'm going to have to squish this in. Okay, so we're going to replace that x with 0 and then that x with 0. So we'll have negative x squared minus 4 times that 0 plus 5. I forgot to color code it. Let me go back and do that. We replaced x with those zeros. Okay, I managed to squish it in. Whew, okay. Then we have 0 squared. Well, that's just 0, so that'll be 0 plus 1. Still minus. We have that minus. And then the opposite of 0 squared, well, that's just going to be minus 0. And then 4 times 0, that's going to be negative 0 again, plus 5. Got a lot of zeros going on. Well, 0 plus 1 is just 1. And then we have minus, well, negative 0 minus 0, that's just all going to go to 0. So all we have left is the 5. And that'll be 1. And remember, we have that negative there. We got to be careful with that negative. Got to distribute that. That's one of the key things for the subtraction of functions that a lot of students, I will notice, forget. We have to remember to distribute that negative. Okay, then we have negative 5. So that'll equal 1 minus 5, negative 4. All right. So now let's take a look at what else we have. This is called the composition of functions. Now this one is weird. So previously, what we were doing here is we had two different functions and we were just adding them together, right? This one, what we're going to do is you're going to be sticking one function into another function. So you're going to be inputting a function into another. So if we have, for example, f, and we call this of, so it's a little circle, don't fill it in. So f of g of x, this is the same thing as f. And inside of f, we're going to input g of x. Kind of interesting. So let's take a look at an example. So we have f of g of x. So I'm going to rewrite this as f, and we're inputting the function g of x into f. Well, what is the function g of x? G of x is 3x plus 4. So that means I'm going to have f of 3x plus 4, because remember, that's what g of x equaled. So now what am I doing? Well, I want to input 3x plus 4 into f. So wherever x is, I'm going to replace it with 3x plus 4, because that is my new x value. Kind of odd, it's kind of big, but we can do it. So we're going to go ahead and replace that x value with 3x plus 4. So we have opposite of, and my x value squared, 3x plus 4. Because that is my new x value. So then that'll be minus 3x plus 4 squared. Okay, and we'll go ahead and leave it like that at this time. All right, let's take a look at b. b is g of f of 2. So now, since g is first, we're going to actually be inputting f inside of g. So that'll be g of f of 2. Okay, well, what is f of 2? Well, we could figure that out on the side, or we can go ahead and do that inside the entire problem. I'm going to go ahead, the first time we do this, I'll go ahead and figure it out on the side, and then I'll continue it in the problem. So f of 2. f of 2 is going to be, we'll see, we have negative x squared is what f of x equals. So we're replacing x with 2, which means we have negative 2 squared. That should be negative 4. So I know f of 2 must equal negative 4. Okay. So if you did that scratch work on the side on your exams, for example, you go ahead and write scratch work. Or you could go ahead and do it in the problem, which is what I normally do. So I'll go ahead and do it in the problem to show you the two different ways you can solve this. So f of 2 is negative 2 squared, which equals g of negative 4. All right. Sorry, my mic's squeaking a bit. Okay, so we have g of negative 4. Well, that means that whatever or wherever I see x, I'm going to replace it with negative 4. So in g, this is g, where is x? Right there. So I'm going to replace that with negative 4. Let's go ahead and do that. So g of negative 4 is going to be 3 times my new input of negative 4 plus 4. So 3 times negative 4 is negative 12 plus 4. Negative 12 plus 4 is going to equal negative 8. And there we go. So once again, you'll notice, if we're just working with x, we'll always end up with a polynomial answer. If we're working with a new input that's a number, we'll end up with a number answer. At least for the most part. Okay, so let's take a look at c. c is h of g of 0. So since h is first, it goes on the outside, and then we're inputting the function g of 0. Now you don't necessarily need to do it quite as dramatically big like I do there, but I tend to do that so your eyes can differentiate. So then h of, and what is g of 0? Well, g is right here, and we're going to replace x this time. So instead of replacing x with the negative 4 like we did last time, we're replacing it with 0, because we're told to replace it with 0. So that'll be 3 times 0 plus 4. So that'll be h times 3 of 0, 0 plus 4. Simplifying, so h of 4. All right, so now we're told we want to find h of 4. So where's h? h is right here. And we're going to replace 4 for the x. So that'll equal 1 over, and we're replacing the x value with 4 plus 1. And simplifying, we have 1 over 5. And we're done. Alrighty, and that is it for this section. Now, this section does tend to give some students trouble, so definitely come by my office hour or ask me questions, because I want to make sure that you understand this. Again, my office hours are there to give you help with the homework or the lecture notes, so please stop by.